Here we
Hello,
are.
everyone. Welcome to the Sensor Journalism series. This is our very first official session, so we are very, very excited to have everyone here today. So a little bit of background about this series. This is an informal hangout that's co-hosted by Alex Fink of the Open Knowledge Cast and myself, Lily Bui. Each weekend in March, we're going to explore different aspects of sensor-enabled journalism by bringing together speakers who have worked with sensors and storytelling in some capacity to discuss some key issues around this space.
And all these sessions will be archived and made available on censorjournalism.okcast.org. At the end of the series, we hope to have built a compendium of information about sensor journalism, co-created by the people who are collaboratively working in this space. We want to say thanks to our media partners, the Earth Journalism Network and UC Berkeley's Citrus Center, for helping us to promote these events. Here we go.
Awesome. So without further ado, I'm going to introduce our topic for today. We're going to be focusing on designing and deploying sensors. So our panelist speakers, if you will, are going to be talking about their individual projects and products, actually. We have Travis Hartman, who is currently finishing his master's degree from the University of Missouri School of Journalism. His efforts have revolved around the visualization of data, statistical analysis, and using sensors to aggregate environmental data. He's currently working at Geographic, which is a creative analytic design firm located in Washington, D.C. We also have Matt Schroyer, who is the founder and president of the Professional Society of Drone Journalists and the creator of the DustDuino, which is an open source air quality monitor that's being deployed globally by the Earth Journalism Network. He's also working as an instructional technologist for OCCC, an educational robotics developer, and a social network analyst for an NSF grant at the University of Illinois. And we also have Shah Selbe, who is working at National Geographic Explorer. He's an engineer, a conservation technologist, and at National Geographic Explorer, he works with communities, NGOs, and developing countries to identify and deploy open technologies that can help with conservation challenges. And helping moderate this session is Willie Schubert, who's a program officer for Internews's Earth Journalism Network, and as an organizer for a global network of environmental journalists. Willie helps to make tools that enable people to connect with each other, find material support, and amplify their local stories to global audiences. He also devotes his time to the development of a free school dedicated to community building through education and to collaborative mapping and audio projects. So as you can see, we have a very impressive panel. And without much further ado beyond that, I'm going to open up the floor to Travis, who's going to kick us off.
Did I get it right? I'm here. Can you hear me? Can you hear me? Okay, cool.
Yep,
I just
you're good.
unmuted. So, yeah, thanks very much for having me. This is really fun to talk about this stuff. Basically, I started downtown in Columbia, Missouri, and there are two bars on either side of my apartment that have roof decks, and they play loud, obnoxious music until the bars let out about 1 in the morning, and I would sit there and just suffer and couldn't sleep, and out of despair comes crazy. And I remembered seeing a panel by a professor out of Lincoln, Nebraska called Matt Waite. He just basically plugged a microphone into an Arduino, and I saw these numbers roll up the screen, and I was like, oh, I remember that. I was like, oh, that's probably a way that I might be able to look at, I tell all my friends, like, oh, it's so loud, I can't sleep. And they say, well, how loud is it? And I didn't really have an answer for them. And so I started thinking about how loud it actually was. I might be able to sort of go from anecdotal and saying so loud to saying, oh, it's this many decibels. You can sort of quantify it. It became a really powerful idea in my head. And I started thinking about the entire sort of noise ecosystem of downtown Missouri, or Columbia, Missouri, and thinking, well, where is it loud, and when is it loud, and does it change over time, and why? And so this idea kind of came together in the sense of talking with some friends of mine, some people that worked at KBIA, which is who I partnered with to apply for a night prototype grant. And we kind of came together with this idea of putting stationary sensors across the downtown area that would wirelessly update a database, visualize the information to sort of allow it to basically like allow people to observe what was going on in the public space, the use and abuse of public space. So that was the general outline of the Knight Foundation was great, and they saw fit to fund the project, which I don't know how far it would have gotten if they hadn't stepped in and helped us out. I was very grateful that that actually happened. The main tenets that we were sort of concerned, sort of dabbling with computers and programming, but this was the idea that we sort of decided to tackle, so we sort of went about it the best way we knew how. The main tenets of the problem, that, as I saw it, were that we wanted to be wireless because certainly didn't want to go around collecting SD cards, and it seemed like being able to close that feedback loop of noise and then seeing how loud it was, and being able to kind of estimate what happened the night before or 10 minutes before, depending on how quickly you updated the map, was a powerful idea. And so we wanted to keep it wireless and have that updating ability. We wanted to keep low power in order to how long we could deploy them for with good estimation, and we needed a robust housing to stuff didn't get. We wanted to be accurate. Really, what's the point of collecting data if you're not doing it accurately? And know exactly how accurate your data is. I envisioned this as a web, sort of, as it evolved, it kind of became the idea of this might be a and so the first thing we tackled, looking into microphones, and we got a bunch of microphones and started testing them, and I didn't know anything about audio engineering. Kind of reverse engineer the data sheet. We got a radio engineer out of Boston to write a pretty basic algorithm for us to sample. We were looking at, I did a little bit of research in noise sampling, and it seemed like they were fast and slow, and you either take a short clip and sample that, or a longer clip and sample. We're more looking at the ambient noise, and we weren't doing any kind of frequency analysis.
Did we lose Travis? Can you guys hear me?
Yeah, I think we might have lost him. Was he lagging for everyone?
Travis?
Did you lose me?
Oh no, I think.
Yes, I'm here.
There's a big lag on your connection, so it's freezing every couple of.
We're missing your important words.
My airplane. How bad is it?
Actually, it's really good now.
What should I do?
It might still be caught on the recording. Sometimes you don't know once it reaches YouTube.
Okay.
Yeah, that's true. Okay.
Should I just go ahead?
Yeah, just go ahead for now.
Okay. I'll just keep going. Oh, sorry, guys. Yeah.
Okay. A hand signal or something.
So, okay, thanks. So yes, we basically reverse engineered the data sheet for the microphone that we'd chosen, and we found that we got about between plus or minus 2 decibels of accuracy between sort of street noise and rock concert. So that seemed like a good starting point. So we moved ahead past that and went into looking into the wireless options. And in looking at the wireless options and the cheap options and the looking for a platform, we ran across an Arduino derivative called Motino, which is this little guy, as you can see. It's a really nice small platform, and it comes bundled with a wireless transceiver. So in the ability to send this stuff wirelessly, it worked out really well because it was small. It had the power on the chip we needed, and they're really cheap. They're like $18 per node. So that seemed like a really good fit for us. We originally looked at sort of using cell phone cards to text the data with an Arduino, and that just sort of grew out of control really quickly. I mean, one cell phone plan is hard enough for me to manage. I don't think I'd be able to do six, but that sort of did alleviate the need for, because we had satellites kind of pinging off and back down to a database. But
Hey, Travis, I think you're frozen again.
But this time in a wonderful
radio
photo.
transmission. Yeah. Am I gone?
You're partially, only partially.
Sorry. I think, is it okay if we move on to Matt for now?
Sure. Yeah, that's fine. I'm sorry.
No,
Yeah, sorry.
sorry. Okay, just now, and maybe the connection will improve later. Matt, are you good to go?
Hi.
Okay.
Okay. Sure. Yeah.
Oh, you just want me to go? Oh, okay, I'll talk. I'm Matthew Schroyer, and I was in a journalism program at the University of Illinois back in 2010 and 2011, and when it came time to do my final project, basically the thesis for the master's program, I chose to focus on environmental justice issues in Southside Chicago, specifically two neighborhoods called Little Village and Pilsen that had some very old coal-fired power plants in the area, and also some smelting plants, both of which were a major environmental concern for people living in the area. And I spoke with people who had multi-generational lupus that was very rare to have in a family like that, and also just hearing stories about burning piles of coal and things like this that happened during the summer. The communities there were understandably very concerned about the situation and how it wasn't getting any better. They were worried about their children going to school and what kind of environmental hazards that those children were coming into on a daily basis, and they had to band together into an environmental justice group and actually go around and collect samples from the dirt and send those off to testing in a lab. They then got those results back that showed indeed there was a very high level of lead in the ground that was not safe at all. And using that data, they were actually able to lobby the Environmental Protection Agency of Illinois successfully to install some air monitors above an elementary school. And the results from that monitoring program helped put a non-attainment designation for the area, meaning that those power plants and the smelting plants had to make some changes in what they were putting back into the environment. And while I was doing this at the time, I thought it was really neat that these groups were able to go out and collect real data to to validate what they were experiencing in everyday life, and then use that to try to get some changes happening on a at the sort of top level of the state government. It wasn't really later until I started working with drones and kind of open source technology that I kind of put two and two together, that instead of sending these test results off to a lab, what if those people had access to a device which would give them that data in real time? At the time, I was spending a great deal of time at a place called a Fab Lab. Fab Lab is basically modeled after an MIT system of similar kinds of workshops that have a set number of tools, anything from simple vinyl cutters to cut out stickers, which is really cool, all all the way up to things like 3D printers and laser cutters and engravers and CNC milling machines that you could mill out computer boards and things like this. And that helped me to build some drones for students and for my own work as a journalist. But it really got me involved in this open source system called Arduino, which Travis mentioned is a really cool system because basically the code is freely shared online. There's a lot of derivatives of the board, so if you don't find something that matches exactly what you want to do, oftentimes you can cobble pieces together and find a solution, or even since these are open source, you can look at the board designs online and make a board entirely yourself, send the plans off to a manufacturing plant, and then out come your specific boards that you can share with the world. So I started tinkering with this and looking at the available sensors. There had been a number of projects like the air quality egg, which had gone a long way in trying to spread the word that the people can have these on a personal basis. You know, that these weren't basically environmental monitors owned by the government or another agency or some outside entity, but the people themselves who want to know about that stuff. But unfortunately, the sensors are kind of hit and miss. The things that actually sense the chemicals and the changes in the environment are not totally perfect yet. Some of them, for instance, for like carbon monoxide, a very dangerous, odorless, colorless gas. Most people have carbon monoxide detectors in their homes to warn them about this stuff. But the ones that you get cheaply that might be of use to a wide-scale program sensing carbon monoxide don't really pick up the minute levels of carbon monoxide that make a real difference. So you get sensors that may not be healthy for humans but might be great for some kind of industrial application. Well, fortunately enough, looking around at the different kinds of sensors that would be great for this kind of program, particulate sensing has come a long way. The kind of big expensive monitors that you find the EPA and other organizations using, expensive, bulky, consume a lot of power, but very precise in measuring the mass of the tiny particles floating in the air. They do this with something called a gravimetric impact, or basically a cascading series of filters. The air runs down through and it hits these filters or these plates, and that signals that a certain mass of particle has hit that plate. And you add those up together over about an hour, and you get a measurement in terms of micrograms per cubic meter of air, which is a really small amount in terms of grams when you think about it, but that makes all the difference if you're actually breathing in this stuff, and especially if the particles are very small, like 2.5 microns, which smaller than the width of a human hair, much smaller, maybe a tenth, or a 20th the width of a human hair. So, understandably, you don't want those in your system. You don't want to breathe them in because then they get in your circulatory system. And the World Health Organization has finally come around and designated these particulates as a Class 1 carcinogen, kind of on the level with cigarette smoke. So they're quite dangerous in a large quantity. They're very much of concern in places like China and India and other places around the world where we have a lot of coal burning for heat and food, but fortunately the sensors have gotten a lot better to now moving towards LED technology or laser technology, using something called MIE theory, M-I-E theory, and that is that when you shine a light and you observe the light that's being reflected or absorbed by these particles, you can count them. You can count the number of particles, and you can maybe interpret something about their quality, which is also important. It's not just that there's particles, but what particles of what. So there's been a lot of advancements in that in the last 3 to 4 years. To use low-cost LEDs to actually put them inside of a sensor housing and give you a particle count. So that was great because that's kind of the biggest challenge, is going off of what's mass-produced, what's the cheapest to put in the sensor, but what also works. So going off of that, I built some prototypes. Ended up in the Tau Center for Digital Journalism, which was very interested in kind of a lot of new digital technologies that could be impacting journalism, drones included, but sensors, software sensing technology. Fergus Pitt gave a really great overview in the last part of the series about what the Tau Center is doing. And so one of the things they did was put together kind of a sort of a meet and greet and begin the thought process of maybe potentially putting together a paper about how this could impact journalism. I brought the DustDuino along, met Willie Sherbert from Intranews there, Earth Journalism Network, and we started talking about, well, there's a lot of places around the world that could absolutely use something like this. So Earth Journalism Network funded a round for their own journalists first to try to test, to see if this was feasible for a journalist to pick up and to understand, so that we had some training sessions out in Berkeley and also at the San Francisco Google office to train journalists to go back to Nepal, Indonesia, Brazil, Nepal, places that could really use some environmental sensing. And with that, we had some pretty good results, but we learned a lot too from the stuff that didn't go very well, and we started independent board design, which hopefully will be manufactured so that more journalists can use that and put that out in the wild. And so that's kind of where the DustDuino project is at this moment. We're looking at maybe potentially a larger scale rollout, but who knows what the future holds. I mean, this is a very interesting technology and it's changing all the time. But yeah.
That's awesome. Thank you so much for that overview. I think we're gonna, so Alex and Willie are actively thinking of questions, and so as you're presenting, they'll keep a note of that, and then we'll go to the questions right after all the speakers have finished. So thank you so much, Matt. Shah, we're gonna move on to you. Do you want to talk a little bit more about your work? And then Travis, we're gonna try to get back to you at the end of that too.
Sure thing. So I'm Shah Selbe. I'm actually coming at this from a slightly different angle. I'm not a journalist. I'm an engineer, and I work primarily with conservation groups. So all this kind of started back in grad school, where I'd always been into the environment, but I started working with the Center for Ocean Solutions, which is based out of Stanford, where I was going at the time. And they were looking at different problems related to our oceans. And one of those problems was illegal fishing, and how you deal with illegal fishing and overfishing happening in our oceans. And at that time, I started proposing some technologies or some new kind of open source methods that we can use to do that. And when I started doing that back, years back, there was not a lot of people who were talking about that sort of thing. And the Center for Ocean Solutions loved it, and they kind of picked it up as one of their projects. And for a number of years, I worked with a bunch of different nonprofits, like Pew and the Waite Foundation, lots of different organizations to bring technologies into the projects that they're working on. And that's things like how they can use drones or sensors to inform conservation decisions about the area they're trying to protect, or to try and identify people who are doing illegal activities or the other types of things in those regions. And so after a number of years of working on that sort of thing, the National Geographic Society actually liked the work that I was doing, and they pulled me into their Explorer program. So that's basically the National Geographic Explorers are people who they think are doing some interesting stuff in their field, and every year they pick 15 or so people in different fields like anthropology, all this sorts of stuff. And so I was pulled into that group in 2013. And since then, kind of this work has kind of continued on, and I've worked very primarily with open source technologies and how I can use them for conservation. So one of those projects is a drone project funded by National Geographic and Lindblad Expeditions called Soar Ocean. And the whole purpose of that is to use low-cost stuff, things like the iris that I have sitting right here, to monitor our coasts. So basically the whole point of that project is to build all the tools and all the lessons learned and flight checklists and everything to give to conservation groups or coastal communities that are seeing illegal fishermen come in. So off the coast of Sierra Leone, there used to be a lot of problems with illegal fishermen coming in, and they didn't really have a good way to document it. They got a boat, but they could never fuel the boat. Well, there's a lot of the stuff that you could do with some of this low-cost drone technology, and so that's where the project was born. So over the last year or so, we've been going on lots of expeditions all over, testing different types of deployments and how you would teach someone to do that out in the field to better document that. And we've moved on to start doing like surveys of marine mammals, seals, and things like that, or even trying to find ghost nets, which are basically if a net gets lost from a fisherman or it gets snagged and pulled off, they roam the sea catching marine life and killing them indiscriminately. So we like to try and find those and pull those out and stop people from doing it. But the main focus of Soar Ocean is to document what's happening and try and like take that and bring that evidence to the authorities and do something about it and actually change like the situation that they're dealing with. Another project that I work on with 3 other of the National Geographic explorers is the Okavango Wilderness Project, and so that's a sensor project. Well, my portion is sensors. Basically, the Okavango Delta in Botswana is this very, very pristine wildlife habitat that's just teeming with hippos and elephants and lions and all these wonderful, wonderful creatures. But all the water and everything that comes into the delta that feeds all these animals originates in Angola. And in Angola, was in a civil war for 26 years. Now there's all sorts of development happening, lots of mining, lots of other stuff that is going to impact the source of the water that leads to the delta. So the whole point of the Okavango Wilderness Project is to monitor that. So we have one of the other explorers that's focused on doing animal surveys, and so he's basically counting the numbers of birds and elephants and all the stuff that we're seeing. And then me and this guy named Jer Thorpe, who runs the Office for Creative Research, and he also teaches at NYU. But the purpose of our portion is I'm building sensors, and he's taking the data and visualizing it. So if you go to into the okavango.org, or even just Google into the Okavango, you could see the website that we created that pulls the data and from the sensors and the expedition. And so what we did with the expedition in 2014 was we went on a 17-day long expedition, and the entire time as we were going through the Okavango Delta, we were taking data, water quality data, biometrics, heartbeats. We had all of the animal sightings. We had different kinds of observations, and we were basically beaming it out real time as we were going through the expedition. The idea was, in the past you had scientists that would go on expeditions to these amazing places, and they would gather all this great data, they would take all these great pictures, and then they would sit on that data until they can publish it and gain all these accolades for publishing that stuff. We wanted to turn that like completely on its head and do a completely open expedition real time, so anyone in the world could see and access the API and pull the data and do whatever they want to do with it. So basically, as we were going through the Delta, you could see us having like sightings, and maybe if like a time when a hippo was charging us, you could see the heartbeat of the people in the boats and how everyone gets scared, and like how all these things play together. So last year's expedition was more of, we put out a few prototype sensors and kind of we're testing the entire system. This year's expedition is a 3-month-long expedition that's starting in Angola, and it's going through Namibia and down into Botswana. And for that one, we have a really detailed water quality, air quality sensor package that's going on the lead canoe that's taking the entire thing. So you're going to be able to see how the water quality changes as they go through that entire expanse. We're dropping off little sensor units along the way. We teamed up with the governments in those countries. So in Angola, we're going to put little cell phone connected water sensors and stuff all the way along the way. And then my focus this year is deploying mesh networks of environmental monitoring stations around the safari camps that are deep in the Delta area. So you'll see all this stuff coming out this year throughout the expedition and all that.
That's awesome. I think I speak for a lot of other people when I say I'm totally jealous of your job. If you want to switch anytime, I'm open to it.
Yeah, it's fun.
I think we lost Travis again. If he comes back within the next minute or so, we'll go back to his presentation. But maybe we can get into the discussion, because I think that's where the most interesting part of these conversations really comes about. So Willie and Alex, the floor is yours.
Willie, do you want to take this one away with your first question?
Sure. Yeah, this is super interesting presentation, and definitely, Shah, that's pretty incredible, the full extent of the material that you've pulled together from these sections. And I guess my question for you specifically is, how, like, when you're an engineer by trade, not a journalist. That's how you started with this process, and I'm wondering, you know, the team that you're using to pursue this kind of project, what kind of people are involved? And what role does each play? Because I imagine, you know, there's the technical specialist, the maker, the scientist, the journalist, and yeah, what kind of team do you need to be able to do this?
Yeah, so that's actually very interesting. So the team that we have for the Okavango project, it's, as I said, it's made up of 4 explorers, and everybody definitely has their own distinct role. Like, you know, so Steve is the project lead. He's the biologist. He knows everything about the Okavango. That's his, like, his baby is that environment. He's the one that pulled us all together. I'm kind of the engineer, the hardware guy, so I know how to build these sensors. I know how to deploy things like that, and so my role is really putting this hardware together and getting it all working flawlessly. Jer, as I mentioned, he's the one who created the website. He actually worked at the New York Times, so he's our storyteller. He's basically the journalist edge of this whole thing. So without him, you know, if you go to the website, you can see how beautiful it is, and we have amazing things planned for the 2015 expedition and the website that's coming out of there. So if you know, without his ability to really tell that story and bring the data and like show it in a compelling way, it would fall flat. You know, there's lots of people who are doing interesting type projects like this kind of thing, but the storytelling aspect, I think that's like key to it. And finally, Greg is he runs this organization called Adventurers and Scientists for Conservation, and basically the whole role of his organization is almost citizen science in a way to get people who need to get like critical data from hard to reach places and then team them up with adventurers that are going out to those places. And he really pulls together like the logistics on how you would deploy a system like this. How do you maintain a system like this? What are you going to do like in the coming years? And like how do we bring people out or train the locals or do all the stuff that we need to do to get something like that together? So I think if we didn't have any component of that team, we'd kind of fall short in many ways.
Right. And yeah, just kind of to follow up, and a few of the keywords that I heard from all 3 when we could hear the static was consistent role of open source, the goal being low cost and accessible. And I'm wondering why that's important, and specifically first to Matt, since I'm interested in, you know, that low cost particulate sensing. So the difference in price between that gravimetric monitor that you mentioned at the beginning and the contrast to the DustDuino, which is using an optical sensor. Mm-hmm. Why is low cost and accessible and open source so important for sensors?
Mostly, I mean, the way I approached it was just how can we get these into the hands of as many people as possible? And it's not going to happen unless it's low cost and accessible. But at the same time, it's a challenge to get that accuracy that Travis was talking about. Fortunately, that's also been a part of one of the changes that's been happening. I mean, certainly there are sensors out there that are not that you wouldn't want to use. But what I think is remarkable is the number of sensors that actually do provide real, useful data. Microphones and basically with the particulate sensing, and with the particulate sensing too, there's different tiers. So, I mean, if you really needed something that was, more accurate than what you get from the kind of $15 or $20 sensor that's used in the DustDuino cube, you could move up to something that's not a gravimetric impactor, but uses lasers instead of the infrared LEDs to do that. And there's actually one on the desk that's part of the Internews project, and so this is just called a Dylos air quality monitor, and it's got basically a fan in the back here that circulates air past a laser, and it does the same thing that the sensor that we use for the DustDuino uses. and it counts particles just with a more accurate laser, and that's about $300. So I mean, that's not something that everyone could necessarily afford, but if you wanted to, validate your data, you could do it that way too. But yeah, definitely, it just all comes down to having as many people as possible being able to use this. Because that was kind of the whole point. Is maybe the accuracy is not tremendous, but if you get a critical number, maybe you start to get a story about the area that you wouldn't get otherwise.
Yeah, I mean, if I can just add to that, I think that was great. I think that's kind of the whole point of what seems like a growing movement in like sensors and these capabilities is the low-cost nature of this. We could do all these measurements with the expensive hardware that's out there if money wasn't a problem, but it doesn't make sense. So the conservation projects that I work on, these areas can protect their marine protected areas or their oceans if they had the very expensive Coast Guard that the U.S. has, right? But the fact that they don't, and they still need to protect these waters, we have to provide the tools, and that's where like this low cost and accessible stuff comes.
Yeah, and I know that this is kind of a big question, but I think that people who are watching this would benefit just from a little bit of exploration of your thought process in terms of how is that cost consideration affecting your design decisions. In terms of, well, I need to keep this open source, I need to keep this low cost and accessible, but I also have to consider science, and I have to consider the reliability and the value of the information that's being created. So I think it would be just really useful to hear how are you tackling that issue in each of your projects.
I guess I'll jump right in with the construction and kind of the components that go into trying to make it low cost and the kind of calculations that go into that. Because I started out hacking on this stuff in a makerspace, and I was very blessed to be in a college town where you had multiple hacker spaces. I mean, most communities don't have even one. So the hacker space per person in the population ratio in most places pretty low. But I started about looking, at the tools in my area, in this hackerspace, and what we could use. Specifically, I mean, a lot of the electronics, of course, are very cheap now, and they're open source. But packaging was another issue for us. And so for packaging, this is a product from a laser cutter, and if I get a little closer, you see these little tiny teeth, and that's called press fit. And so if I get enough of these together, it can actually fit together in a cube. See if I can do this right. Oh, it's upside down. There we go. I can put them in a cube, and that can become a housing to put all the electronics. And this was actually a pretty early version of the DustDuino. And that was made using a laser cutter and just a flat sheet of acrylic plastic. So the idea being that I could do that in my own hackerspace, but if there was another MIT Fab Lab or someplace other with a laser cutter halfway across the country, I could just send them the plans and they could do that. But there's also 3D printed parts that we've been experimenting with too. I mean, the 3D printer itself is still pretty expensive, but the cost of the filament is decreasing along with the cost of the 3D printer. And so those are all things that we looked at, is additive printing and desktop laser cutting and things like that. Again, accessibility to those tools is still pretty small, but the idea was that if you have enough people and rally around a makerspace, maybe you could do this at a low enough cost.
Yeah, and I think for the stuff that I work on specifically, the low cost was one of the primary requirements. There's not a ton of environmental funding out there, and if there is, like if you look at the funding that we get for the Okavango project, that's going to go into the expedition, and having 15 people spend 3 months in sub-Saharan Africa, right? So that's an expensive thing to do. So when it comes down to the technology, there's a constraint on how much you can do with the money that's available, and that's thankfully now we can do a lot because of it's basically all the sensors that this stuff has enabled us to create as a result of it. So I think whenever I'm looking for a sensor element or putting together the final system, cost is literally something that I think about on a daily basis, because if you can't get the cost down, in my opinion, what's the point? Like it's just there's nothing new coming out of it unless it's low cost and accurate, which is kind of the holy grail. But I think we're getting there. So.
Right. So
did you have another
I've got
question?
one more question, but Alex, do you have?
You go.
Sure. So, I guess since we lost our journalist on the panel to the shoddy airport Wi-Fi, but I'm wondering in terms of since you guys are much more focused on the design and the manufacturing, the engineering, when you're at the very beginning of this project, how did you did you consider how the project would be interpreted in a narrative form rather than as a data stream? And how did this influence your choices for the types of information that you were sensing for?
So I can go ahead. So the narrative part in terms of like the things that I work on is huge, right? So with like Soar Ocean, right, with the drone project, I want to be able to tell the stories of those communities that are dealing with this sort of thing. Like how are those communities going to be able to show what they're going through, right? Because we have all these coastal communities that for generation after generation they've lived off the sea, they've kind of built their livelihoods off of it, and now they can't because the overfishing problem that's happening off their coast is just kind of getting rid of their not only their only source of protein, but their only livelihood that they know. And so that's a story that needs to be told and that needs to be shown, and it's a difficult one to do without compelling visuals, and that's what the drones can allow us to do. They can show us what's happening out there. The storytelling aspect of Into the Okavango was there from the start. We knew that that's like a story we wanted to tell. The reason why we're in there is because of what we see happening in Angola and the worry about the impact that it's going to have on this critical elephant factory of Africa. So that, we knew all along that we could tell that story, and we knew that the data that we collected is going to make it that much more compelling, and I think you'll see more information coming out in the coming years, but National Geographic is getting behind us in a big way in that, and so you're going to see that becoming a bigger part of the National Geographic story as well, both through the magazine and documentaries and stuff like that. So.
Yeah, Shah had a great point about the people who are living in this environment, which is being sensed. I mean, that's huge, because I mean, we might be coming in with sensors, but this is something that they have to live with day in and day out, and they're honestly the best sensors that you could find because they live it. And the sensors really provide a means to collect and validate data in terms that can be compared with other places. But the story collection behind those numbers is just, I mean, very important. I mean, the people I was talking with in Pilsen and Little Village, I mean, they had real concerns that couldn't really be explained in terms of, lead numbers. So whenever you're collecting a number, I think it's always important to think about who's impacted by the numbers, and why are they this high, and just really talk to the people. Another instance that I had that a thing like the DustDuino would have been really handy to deploy was every year there's about 200 tire fires in the United States, and I mean, every time someone has to get an old tire off their car and dispose of it, it ends up somewhere, and those tires they don't biodegrade. I mean, they stay around for a very long time, and if you get enough of them piled in an area and there aren't sufficient safety things being followed, they can catch fire. And this is what happened in a neighborhood close to where I lived in Urbana, Illinois. You had about 1 million of these tires go up in flames at one time. It took 2 days for the fire to be put out. And the state EPA evacuated about 500 homes, about 2,000 people. to leave the area based on environmental data of some kind, which I tried to find out through Freedom of Information requests. And I waited about 90 days and heard nothing, and had to talk to the state attorney general's office to ask them, well, what's going on with this request, and I didn't get data back. Even though they had obviously made some kind of assessment that it was unsafe for these people to live around this tire fire, I still couldn't find the numbers. But what I did find were emails from people like the principal of the elementary school in the area saying school is starting in a matter of weeks. Can they meet at our schoolhouse? Or parents saying that the children are tracking in soot on their feet and we have no idea what this is. Can you tell us something about this? Is this even healthy? And so that's all stuff that's not data, but it's very important to the story, and it should never be ignored. And that should always kind of be in the forefront when deploying sensors. These might be numbers to us and numbers to science, but this is a real life circumstance to a lot of people.
Can I jump in with a question? I'd just like to hear from both of you what challenges, I think you're both working in very different contexts, and I'd like to hear what challenges you've encountered actually deploying sensors. So, like the legal challenges, ethical challenges if there are some, and then also that practical challenge Travis started mentioning of do we put an SD card in or a Wi-Fi, to transmit data back? How do you deal with these kinds of deployment problems that you run into? And whoever is ready.
I'll go ahead and jump in then. The major deployment problems that varied by the kind of applications. I mean, when I went through developing the DustDuino for the first time, I had access to the Wi-Fi in my home. I also had a power outlet. So those are two very important things that I had. A means to connect to the internet, to send data off to a server for it to be graphed. I also had a really reliable source of power for all this. Well, that's not the case in a lot of deployments where you need to know about certain qualities of the environment. Specifically Mongolia, where we have where Earth Journalism Network has a ongoing relationship, and there is a lot of concern about burning of organics. And for that deployment, we actually had to rethink the design of the DustDuino into a solar platform. And solar panels are not cheap, but they're getting to the point where you can use them for these small sensors, and basically had to rethink the code to get the sensor to sleep for a certain period of time so it wouldn't be constantly running. We had to do a lot of calculations about, okay, how much energy are we collecting from these solar panels, and is that going to be enough to power our our module? So I mean, and also connectivity, because we had to send this data through concrete buildings, and so we also had to look at the power output of the radios. So that really influenced kind of where we're headed now, as a design that can suit multiple deployment issues. And you can also build it to just store data on an SD card, which is fantastic if you want to just run on a battery for an extended period of time and don't need that data transmitted. But there's a lot of cases where that's simply not the case. But you also asked a question about limitations, and since Shah and I do work with drones can also be simply thought of as a as a platform for sensors. I mean, a lot of people put cameras on their drones as a first step, and the camera really is just a sensor for light. And it's really cool. It's a really cool piece of technology. The price has gone down, the accessibility has gone up, but you do have to worry about things like laws in the United States and wherever you're flying. You have to worry about safety concerns. You have to worry about the security of the people on the ground. Maybe they don't feel safe with this thing flying around, or maybe they or maybe you need maybe it's just a matter of communication, letting them know what you're doing. But they can look kind of scary, but they're a very neat tool, and I think a lot of it in that part is just outreach and talking with people.
Yeah, that was a good point about the drone thing. So, when I first started working with it, people thought of them kind of differently than they do now. So, one example is I had some projects that I worked on in the Caribbean, and so but when I first started working on it, lot of the people on the islands in the Caribbean, they thought of drones as a bad thing. They just heard of like Afghanistan and the stuff out there. They knew about the drones that flew over to try and find like narcotics smugglers in their region. So when you talk to them about drones, they're like very scared about it. But that has changed. Like, you know, the conversation about drone is evolving like so quickly because of these commercial platforms that are starting to get everywhere, and everybody's buying them for Christmas presents and stuff like that. And a lot of that's like really shifting. Now my work is inherently complicated in its deployments, and you know, I'm trying to get out there into places that don't have a lot of that infrastructure, and they don't have a lot of kind of the stuff that makes deploying these things easy, you know, Wi-Fi or easy access to power and things like that. But also they also don't have a lot of like the legal challenges that we do in the U.S. You know, flying a drone in a lot of countries is easier because there's no laws against it, whereas in the U.S. it gets a little bit more complicated depending on what you're doing with it. Deployment of these things and connectivity are the two major things that we focus on when we're looking at doing like this into the Okavango project, because I mean, we're putting an electronic platform in the middle of the wetlands in the middle of nowhere, you know, far away from any kind of cell towers or so it's it ends up becoming a very complicated process in terms of how do you mount these things? Are they on buoys? Like, are they on poles? How do you protect the poles from a elephant or a hippo that wants to rub up against it and scratch the side? Or there's lots of implications, but they all end up being solar powered. And then if we're near camp, we can piggyback off Wi-Fi in the camp. If we're near cell towers, we can send them via SMS. But like even that, we ran into some problems. When the first 3 prototypes we put out in the Delta were SMS based. They're cell phone based, and we used SIM cards, orange SIM cards, and just kind of the easiest way to do it at that point was we were sending the SIMs through to a Google Voice number and then porting that, basically parsing that onto the website. Well, it turns out we got out there and we found out that Google Voice considered text messages from Botswanan cell phone numbers as spam. So basically, the night before the expedition, our entire framework fell apart, and we had to like sit there, hacking in the middle of the Delta before we had got to leave on our expedition. And we found another gateway. We changed some of the code to be able to do that, and it ended up working. It worked actually all the way until this morning when I got an email from that gateway provider, and they basically changed the number on us. So it's like a running process to try and figure this stuff out.
And if you don't mind me adding just a little bit to this question, because I think it's really a critical one. And I mean, I think that part of the role of journalists, like some of the barriers that we've faced in terms of journalists getting access to this as a platform to improve their reporting and their storytelling, when Matt and I worked together to provide the first 20 devices. We built the first 20 devices last May, and we handed out to journalists to take back to 10 countries and just see how it would work and see what problems we would run into. And the first one is clearly a technical problem. Like, it's just brand new for a lot of people around the world. Like, how are they even going to figure out how to configure these things, to build these things? So the lesson from that was that we've got to make it simpler and easier. The next kind of thing was that the contexts were so unique and different from each other. I think, what Shah's been talking about with, okay, well, in this situation we need to use Wi-Fi, and in this situation we can use GSM. So the response was we need to create a board, a PCB, the motherboard, the flat, that is able to handle all of these different connectivity options, so that if you want SD card, you don't want to send this to the internet, okay, you can support that, or Wi-Fi or mesh network. We need something that will be flexible enough that it can work in a variety of contexts, including with solar power or directly plugged in. And I think the last kind of unexpected hurdle was in logistics. And for me, I work with journalists like in training, and I help as an editor sometimes on stories, and now all of a sudden I have to manage a supply chain from 6 different companies, like in 3 different countries, to arrive in 4 different places at the same time to actually do this, and that's really hard. So I think what we really looked for over the last 6 months is to find that agile manufacturing capability so that we could produce, so that the accessibility question is also a physical question. You know, can you physically get the tools you need to put this together? And, you know, shipping across countries and dealing with customs. I think customs is actually the hidden political problem more than the deployment, like it would be with drones at this point. It's like, how do you actually get these things through customs and not pay double or triple the price? And I think that it's that kind of a relationship, like Matt mentioned with makerspaces, or Shah mentions with his, you know, friends at the New York Times who are a part of this project, is that when we start engaging with those communities, they start becoming journalists in a way. That a maker can become journalist by providing information that didn't exist before, that's in the public interest. And so I think that going forward, what's really exciting is to start seeding these kinds of collaborations as a way to overcome those technical barriers, those financial and access barriers, and the political issues of just even sending it across a border.
Which is, I think, a great place to draw us to a close, actually, with that, Willie. I'm wondering if anyone, Matt or Shah or Willie, do you want to add anything else before we close on this thought, or on any of the other stuff that we've picked up over the course of the hour?
I mean, the only thing I want to add is, you know, I think that there's a lot of really exciting stuff happening in the space, and, you know, we've talked about maker spaces and the opportunity out there. A lot of the focus of my work, particularly around the sensors, is around like STEM and like reaching out to young kids and like showing that you can build these sorts of sensors cheaply and quickly. You know, there's a STEM project that I like to work on with kids where we build basically just water temperature sensors with Arduinos and put a little SIM shield on there and text message the temperature reading. And you can put something like that together in you know, an hour or two with a group of kids. And I think that there's a lot of power in that, because you can see that these sorts of things are accessible and they're easy and they're not expensive, and that you know, communities all over can do that. So we're hoping to do something similar to the Okavango in the LA River, so you can see like the differences in like a urban river environment versus like the Delta. I think there's a lot of like really amazing opportunities to tell different stories and engage a lot of people. And I just, you know, everybody who's working in this kind of field, like I always try and like stress that like we should be taking advantage of all that. Right? We should be doing some really great things with that.
Yeah, I'll echo those sentiments too, because the outreach is going to be the critical part of getting these networks up. I mean, there can be great advancements in the manufacturing and, you know, of accurate sensors, and, you know, the price coming down, kind of like with these particulate sensors. But so many of these projects require teams of people with different expertise or communities. You know, makerspace is great, but it's just one of many places where people can get together, for instance, to make a DustDuino or to make, you know, a sensor for the water. And that's really, you know, the community around it is important, because not only can they take on the you know, the deployment themselves when you know, a crisis arises or when they're concerned about it, but they can also make enhancements and do things and change the design and tweak the design in ways that helps them and might help another community, you know, on the other side of the planet. And then they just release that code out into the wild, and it's I think this is kind of the highest ideal of the open source movement, is you know, sharing not just you know, interesting fun stuff, but things that also have an impact for STEM education, so they learn about how this technology works, and also it empowers them to make the devices themselves. So I think in proceeding in sensor journalism projects, it's important to understand those communities, you know, and what they can get out of them. But I'll just close on that.
Yeah, I mean, one last thing. I think the people on this call, like, they're doing amazing things, and I think this is exciting because, you hear lots of people talking about connected devices and Internet of Things, but I feel like there's not enough discussion about like Internet of Things, but for the planet, like Internet of Living Things, and like how this kind of environmental sensing is doing much more important things than possibly like having a connected refrigerator or something like that.
Willie's smiling over there, but I'm not sure about what. So just one last question, actually, for all three of you. I think there's, Shah, as both of you are mentioning, this is really exciting stuff, and I think that folks might want to get involved specifically in the kinds of projects that you're working on. If they're interested in being part of DustDuino's development, or Shah, some of the projects that you do, how do they track you down, and how do they start? Because I think it's kind of intimidating to see what you've already developed, and if you don't think of yourself as a maker or an engineer, but you see yourself as a journalist starting to get interested in this, where could you get started learning about it or contributing to it?
I mean, I could probably. This is something that we've thought a lot about at EJN. So there's a few places. The first one is, we've been working with the public lab to put as much of the research and development process of DustDuino onto the public lab's website, because that is an open forum. It's an open community, and we want to participate and run as much as we can through there because of those ideals and because it is explicit about the community elements of it. So the first place is the DustDuino page there. The other thing is, and I think this is an important point to make about how not all communities are the same, and not all communities are going to respond to that same kind of a thing. I mean, what the public lab is about is environmental justice and providing tools for people to help understand their environment so that they can improve upon it. But we also are journalists, and we have another group of a place where we house similar documentation at geojournalism.org. And geojournalism is kind of this idea that we're able to integrate Earth observation into environmental media, from sensors like the Earth to the satellite. And that combination of both the satellite and the sensor in combination can really help enrich and provide evidence for storytelling. So the important thing that we've done with our website, geojournalism.org, is create a space specifically for journalists to receive tailored tutorials on data journalism, open source software, hardware hacking, and also by different regions, so you can find different projects that relate to things that you want to do. And so I think this is the start of saying, look, we all are attached to different communities, and different communities have different needs. So why not build more resources that are specifically tailored to that need, and then utilize things like Creative Commons licensing to share that knowledge across platforms. So that's kind of my perspective on how we do that.
Matt or Shah, did you want to add anything to that?
Yeah, I mean, I guess I'll just say there's a lot of great communities online, and there's a lot of resources available for people to collaborate and participate. And I think the open nature of it is fundamental to it. If anyone's interested in helping alongside some of the stuff that I'm working on specifically, Soar Ocean or Okavango or any of the other conservation projects, they can always just reach out to me on email or Twitter or something like that. We can always use help in these sorts of things. So
cool.
Yeah. I'll also extend my own email address here in the group chat. But Willie mentioned the public lab, which is a great place to collect information and work from it. Maybe produce some of these tools yourself, and then also contribute back to the community and start really interesting conversations. And that's a cool way. But a lot of people do also just reach out to me through my website, mentalmunition.com. I've helped journalists answer questions, and also even 13-year-olds working on science projects. I mean, it's all the same kind of group to me. And it's really cool. But yeah, I would suggest if someone wants to get involved in the DustDuino project, either reach out to myself or to Willie. Look at the Public Lab website. But largely, if someone is just interested in general and just kind of tinkering with this stuff, look for people in their own community. There might be a makerspace or hackerspace or Fab Lab or whatever workshop or whatever they want to call it in their own community. So just do a search for that to begin with. Maybe search for a school that could be using some technical expertise with coding but in general, I mean, the hacker communities I've gone to are just very open to people coming in off the street with crazy ideas like let's sense particulates and saying, okay, let's figure out doing that. I mean, it's generally a very helpful group of people. So that's what I would recommend.
Awesome. Thanks everybody. Thanks a lot, Matt, Shah, Willie for being here, Willie for moderating today, and I'm sorry we lost Travis, but I'm glad we got him a little bit at the very beginning. Really looking forward to the next show as well, which will be next Sunday. And all of the information about this, of course, is on the Censor Journalism site. That's censorjournalism.okcast.org. And we'll put up links as well to the conversation that happened throughout, so you can find Willie, Matt, and Shah, and all of the things that they mentioned too. So thanks a lot, everybody, and take care.
Great. Thank you.
Thanks for having me.
Thank you.